Hello, calculus students. This is Math 181, section 4.3 and 4.4 together, derivatives and shapes of curves. So we're going to analyze the first derivative and the second derivative to tell us something about the graph of f. Okay? And the first derivative is going to give us information about increasing, decreasing, and local extrema. The second derivative gives us information about concave up, concave down, and inflection points. So we got to keep that straight. So let's see. Increasing, decreasing. If f prime of x is greater than 0, that means positive on an interval, then f is increasing on that interval. If f prime of x is negative, less than 0 on an interval, then f is decreasing. So the derivative is saying something about f being decreasing on that interval. Now, let's take a look at a graph of f. So this is some function f, and you see it's increasing and then decreasing. We talked a little bit about that in the last section. The derivative is the slope of the tangent, and you notice that it's going uphill. It's positive, so that indicates increasing. So if the derivative is greater than 0, we've got a function that's increasing. A derivative that is negative indicates that the function is decreasing. And this right here would be where the derivative is 0. Okay. And that gives us a local maximum. Now, local extrema. Suppose that c is a critical number, and we know about c being a critical number, and f of c is defined. So we're looking for where the derivative is defined and equal to 0. If f prime changes from positive to negative at c, then f has a local maximum at c. If f prime changes from negative to positive at c, then f has a local minimum at c. So we're just talking about increasing to decreasing, like over here. The derivative is positive, derivative negative, local max. Decreasing to increasing, we've got a local min. Make sense? Concavity is a little more complicated to see. I mean, this first part's not too bad, but the second derivative talks about concave up and concave down. And concave up, you want to think of it as kind of a smiley face, and a concave down as a frowny face. If the second derivative is positive, so that means that the function is concave up. If the second derivative is negative, then the function is concave down. So here's concave up, and here's concave down. And what's going on is the second derivative is positive. That means that the derivative is increasing. So if you see this derivative is negative, then 0, then positive. So the derivative increases, giving the second derivative positive. But what I end up doing is just memorizing that when the second derivative is greater than 0 on an interval, positive, then the function is concave up. Concave down is when the second derivative is negative. Now let's take a look at this. So right here, concave down, frowny face. Notice that the second derivative is negative, and that's my little arrow there. F prime is decreasing. Look at f prime. F prime is positive, then 0, then negative. So along this curve, the derivative decreases, which indicates that the second derivative is less than 0, or just the second derivative is negative. Don't think too hard about that. What we'll do is kind of a routine to find out concavity. Inflection points. If the second derivative changes, see up here? Here we're talking about the derivative changes. If the second derivative changes from positive to negative, or from negative to positive at a point, and f is defined at that point, then f has an inflection point at that point. So if we look here, this is concave up, then concave down. That is considered an inflection point. This one's concave down to concave up. Here we have inflection points. Kind of a demonstration of some inflection points. And I'm going to come back and do some examples, and the examples are going to be given all kinds of functions. I only have 6 functions here. Believe me, they take some time. We're going to analyze the first and second derivative. We're going to find all local extrema, find the intervals of concavity, and find all inflection points. So I'll be back.